One of those.
Good morning.
Good morning.
Might have some.
Good morning.
Members.
Good morning.
Okay, ladies. Any questions about chapter 15?
Yes, can we do number 3 on the chapter review on page 261?
Okay. You said question number 3, right?
Yeah.
So which of these statements regarding a bit of a computer memory is false? So first of all, yes, okay, what was a bit? Because me says, okay, that's the basic unit of computer memory. Here?
Yes.
Okay. Now the first statement says, okay, yes, it is the smallest element of an image. And that one is actually, that's okay, that's false, because, okay, the smallest element of an image was what we call a pixel. Of not just picture or image, we can actually say it's okay, a digital picture or image. That was what we call a pixel. Okay, now a bit is bistable. Why? 2 raised to power n. Clear? But we mean is okay, said I was going to say okay, 2 raised to power 1, which means is okay means 2. So we can say okay, 2 shades is what we called bistable. So 1 bit actually is going to okay be bistable. Okay.
Yes.
Is a component of a digital scan converter. Means because okay, it has to convert it from analog to digital. So all those 3 is okay were, and we can say it's okay, 8 bits makes up a byte. Right? 8 bits was what we call a byte. Okay, where we then could say is okay, that 2 bits or 2 bytes, which will be the same as 16 bits, would be a word.
2
Okay.
bytes.
2 bytes. Each byte is going to be as 8 bits. So 2 times 8 may come 16, right?
Oh, yeah.
Makes a word.
Um,
Okay. Now, if you go into yes, okay, you can say it's okay. Let me show you what I mean. Let's see. Oh, look, my dear. Can you see this directory here?
yes.
Okay, now these are mainly yes, okay, just different files. What you see written here. 113 KB, 32 KB, 104 KB, 86 KB, so on so. What does that KB stand for?
I think it's gigabytes or kilobytes.
It's going to be as okay kilobytes. Okay, not on the go kilobytes, right? Okay, so that pretty much okay tells us okay as the size of the document. Now here that also gets all this okay. These are pictures, but yes, okay. Even if you go to yes, okay, you can say it's okay. Regular Word documents or any file, yes, okay, is going to be expressed in. But it's okay how many bytes they're made up of. Okay, you may see something like okay as MB, which is going to be as okay megabytes. Okay, so that mainly tells us okay how many bytes of memory that okay as each image is going to as okay each file is going to as okay occupy on your hard disk or whatever storage media you are storing it on. Okay, so the only one that is okay, the only statement here that's okay that didn't make which wasn't yes okay true when we're talking about yes okay a byte was that is not the smallest element of a digital image. That was what we actually yes, okay will call a pixel. Is that clear?
Yes.
Okay. Anything else?
Question 15.
Huh?
Question 15.
15.
Yeah.
Okay. You say 1.5, right?
Yeah.
Good. And I mean, it's okay, just ask the same thing about it's okay what a PAX is. Okay. Now it's okay, all of the following are advantages of a PAX system, except from. That's okay when we say PAX system, just remember okay, it's okay, that's most likely it's okay going to be it's okay digital. So directly or indirectly, as okay, may ask about okay, what could be as okay the advantages of a digital system, except from the data will not deteriorate over time. That is true. Clear? Okay. You can print out a thing, especially as okay if that is you can say it's okay analog printout. Okay. you get a receipt, for instance, that's okay for a purchase that you made at any shop at some point. Okay, now that printout, that is analog. And so yes, okay, after a certain time, yes, okay, what do you see? Yes, okay, that the ink actually is okay, disappears. Okay, so okay, that would mean yes, okay, that it deteriorated over time. But if let's say I have a digital receipt of that purchase, yes, okay, it is stored in a memory, it's not going to change. Did that make sense?
Yeah.
Oh yes, okay. At least that one is true. Okay, images can be delivered to distant locations on an imaging network. And of course, that's okay, that's true. You have an image on your PACS, on your computer. You can actually, that's okay, electronically, that's okay, deliver that to, that's okay, somebody else's PACS. Or if they are in the same DICOM, yes, okay, they may be able to, yes, okay, say directly access it. So that is true as well. Okay, all the archive studies and reports can be reviewed easily. Of course. Clear?
Mhm.
Images have higher resolution than what appears on the system's display. No. We can actually say that, okay, yes, the image's resolution here is going to be, okay, the same as, okay, what you see on the display. So that one is false.
Okay.
You can Photoshop an image. Now, if you Photoshop it, and due to that, yes, okay, you can say it's okay, improves its resolution. Okay, now two things will happen. First of all, it's okay, this will then shake up because it's okay, more data. Right, okay. But okay, meaning it says okay, that's just going to, that's okay. It says improve, yes, okay, the resolution on the displayed image. Did that make sense?
Yes.
Okay. Anything else?
That's it for me.
Hmm. Yeah, what about the questions in the exam review? Why you guys didn't try on those? Yes, girls. So when we only have, yes, okay, only, yes, okay, black and white. That was what we call, yes, okay, bistable. And please keep in mind, go that, okay, bistable is going to, yes, okay, be 1 bit in pixels or per pixel. Okay. Please keep remember that, okay, this is going to be, yes, okay, because that's okay, the greatest contrast. because there's only okay two colors. There's black and there's white. And due to okay, there's greatest contrast between the two shades that we have. It's okay, the poorest contrast resolution. Okay. We can also say that okay, this with the greatest contrast actually was okay as the smallest grayscale. Now 439, yes, okay, just remember that number. That we have to have okay, at least 20 frames per second. Or we can actually say okay, have okay as a frame rate of 20 hertz. Okay. Or because it's the images to show no flickering. Now, if you say that we have okay as a frame rate of 20 seconds or 20 frames per second or 20 hertz, what's going to be the T frame then? That's close. If you have 20 frames per second, what is going to be the T frame? Close. If that is your frame rate, 20 frames per second, then what is going to be your T frame?
1/20.
Horses, donkeys,
Hertz.
huh?
Hertz.
Pardon me? Nope. Not hertz.
Is it the CM or
CM.
um,
What does CM stands for?
centimeters?
No.
Or- no?
So this question could we are not asked, then it's okay. The number appropriate number of frames. But what's going to be as okay the time for each frame to be completed, which is a T frame, which is going to be as okay goes the unit of time. which will be seconds. Let's look at it this way. For instance, okay, we were able to just okay answer 10 questions in 1 hour. It would take us just okay 1/10 of an hour to answer one question. When you go for your board, they're going to say, okay, these are the amount of questions that you have. And this is the time that you have. The better management is that, okay, you able, yes, okay, yes, okay, you should calculate. How much time am I allowed to, yes, okay, allot for each question? Otherwise, yes, okay, your time will be off and you're up and you actually, yes, okay, not even halfway. So if the T frame is okay at $120 a second, that mean that okay, as you will be able to just okay see that movie, or it's okay a sequence of images without any flickering.
Daniel? Daniel? Can you tell Mama to give me my bank card? Tell Mama to give me my card?
Now, what is the original purpose of an ultrasound system analog scan converter? We'll talk about that in the next chapter. Okay, good. Question number 441. Okay, which of the following best describes as okay an analog number? Yes, okay, give the example. Okay, the beta of the person, but you can say, okay, 100.1, 101, 0.246 pounds, for instance. Where we made is okay an analog, and please keep in mind, goal that's going to be as okay. What we're going to call that's okay become relevant and okay as the next chapter. Either okay as analog numbers were limitless, or we can say okay with no limits. Or what your book made is okay just says okay as I mean continuous numbers. Well, the next question, okay, true and false, which means it says, okay, a digital representation of a number, which will be an analog number, can be or can achieve only as okay specific frequency values. And that was true. Mainly because okay, we said okay, digital numbers were it's okay, discrete was okay, had limits. Anything else goes. Question number 443. Digital scan converters do not use computer technology to process electronic data into images, and that is false. Right, okay, digital scan converters. I would say that when you say digital scan converter, what do you mean? It actually goes from analog to digital scan converters. Okay, they use computer technology to convert analog information into digital information. Okay, that okay is whatever words or yes okay data that you were transmitting was going to be as okay converted into as okay bits or bytes. Any word they were wrote, for instance, we can say as okay blue. Well, just going to be as okay a series of zeros and ones. As long as it was made up of okay as a total of 16 bits or 8 bytes, it becomes a word in computer. Right, okay. So if I type the word blue, B-L-U-E, okay, as you have your letters on your keyboard, okay. But when that letter, for instance, okay, is going to okay be stored in my digital document, it's going to be okay a series like this. Yeah. So that was going to be okay, you can say analog to digital converter. That did that conversion. Now, of course, you don't want just okay if you type the letter blue on a document and you open that document, you don't want to see just okay a series of zeros and ones, right? Okay, does that make sense? So yes, okay, whenever you open this document, you actually hopefully yes, okay will see yes, okay the letter, or yes, okay the word blue written on the document. Did that make sense?
Yes.
Because that digital format, or yes, okay digital info, has to be as okay converted back into an analog format. So sometimes it's okay, God forbid that it happens, that you open this document here, and the thing that you see is not the word blue, but you see just okay a whole lot of okay different, yes okay numbers, digits, shapes, emojis, and things like that. That's because in many instances, okay, this scan converter here maybe had been gone. Or the yes, okay, the program that your system will use to convert the digital format into an analog format for you to be able to see it on this image on your screen is messed up. And that's mainly it's okay, going to be it's okay the job of a virus. Either it's okay, the converter is messed up, or the program that you are using is attacked by a virus. Which means will do is okay, will not be able to okay, you can say decode this series of okay ones and zeros back to the word blue. Did that make sense?
Yeah.
Question 4, number 444. Now we have two systems. We have system A and we have system B. Now, two digital scans converter are undergoing evaluation. Now, both produces images of same size, so we can say, okay, image size. That just says, okay, that they are, that just says, okay, 10 square inch. Yeah, so they are of the same size. Okay. Now system A has, okay, has 1 million pixels. And system B has, okay, 2,500 or 250,000 pixels. Now which system? Okay, now let's say, okay, with 12 bits assigned to each pixel. So you can mean it says, okay, bits per pixel is going to be 12. Okay, now which system? Which system is going to, yes, okay, more likely have the capability to display very small details in an image. Now what they mainly mean by, okay, yes, very small details. Here actually, yes, okay, means better spatial resolution. Now, what we mainly can say here is, okay, that this image here, that's okay. If it's okay, both of them are, okay, 25, oh, sorry, 10 square inch. But you mean is, okay, say, okay, here we have, okay, as 100,000 pixels per square inch, which becomes, yes, okay, it's pixel density. Where here is, okay, your pixel density was going to be, it's okay, 200 and 2,500. Oh, yeah, no, sorry. Say 25,000 pixels per square inch. So this had a lower pixel density. This will have the greater pixel density, which may of course that would be system A that shows the better details. Did that make sense?
Yes. Yeah. Now, if we increase the pixel density, okay, so what happens to a digital image when the pixel density increases? Clear? Now we can say, okay, that's going to just, okay, improve what we call is, okay, the spatial resolution. Clear? Please, ladies, the increase in pixel density is not going to improve your contrast resolution. Okay? I have a question. Why?
Huh?
Why wouldn't it increase the contrast resolution?
Because this contrast resolution is going to wholly and solely be determined by, okay, as the number of bits per pixel.
Okay.
Did that make sense?
Yeah.
Okay, so yes, okay, you can say it's okay if you find yes, okay, increase the pixel density. What did that mean? That actually means that okay, yes, that there was a decrease in the pixel size. And if you said okay, yes, if each pixel was this big contra to this big. That would mean that okay, yes, in this instance here, we says okay, we will have okay, as a great pixel size, and here we have a small pixel size. Now, if you have a great pixel size, that would mainly mean that okay, there's going to be a low pixel density. Because the greater the pixel, less pixels was it that you were going to be able to okay fit into yes, okay, 1 square inch. Here he says okay that your pixel size was 1 square inch. You may as okay just have had okay the pixel density of 1. Because in 1 square inch, yes, okay, you are only going to be able to fit in 1 pixel. Whereas if you say it's okay, here is okay, the pixel size was a quarter of a square inch. You will actually is okay be able to is okay have a greater pixel density. Which was going to be is okay that you have 4 pixels per square inch. And this was 1 square inch, but okay, you actually were able to have 4 pixels in it. Where the contrast resolution, my idea was mainly going to be as okay, only and solely be determined how many bits did we have in this pixel, or how many bits do we have in this pixel. That will be determined as okay the contrast resolution.
I have a question.
Mhm.
So the contracts improved with an increase of number of bits?
What did you say there?
I said, so the contracts resolution improves with an increased number of bits?
Yes,
Okay.
because with increased number of bits, what do you have? You end up having a greater grayscale, right?
Yes.
Because of this, okay, you can say okay, increased number of grays per pixel, or varieties or shades of gray per pixel. So the greater the varieties of grays of shades of gray per pixel is going to be, you will have okay, as a greater contrast resolution, a better contrast resolution. But you also, yes, okay, and that's what's going to become relevant in the next chapter is that you also have to think of, okay, yes, the more bits per pixel, yes, okay, is going to take more of memory, take up or occupy more memory on the system, right? Because that file is going to become bigger to be stored. Did that make sense? You have, okay, have any of you ever been out there just, okay, purchase a digital camera? Or when you buy as okay video or as okay phone you have, it basically says okay, it comes with this many megapixels of a camera, right?
Yeah.
Okay, now you know what okay what that megapixel means. Mega is 1,000,000 pixels.
That's okay. Pixels per square inch. Did that make sense? Now, if you, for instance, okay, have XYZ, that's okay, giga memory or gigabytes. Well, okay, yes, the greater the megapixel value of your, okay, yes, your camera is going to be, that will mean that, okay, yes, each file is going to be bigger, which means that, okay, will reduce the number of pictures that you are going to be able to just, okay, store on whatever memory you have. Did that make sense?
Yes, it did.
So that's okay. What happens when, okay, yes, what happens to the digital image when the pixel density increases? Well, okay, yes, the spatial resolution is going to, yes, okay, increase. Now, what we know by, yes, okay, increasing spatial resolution is that, okay, yes, your temporal resolution is going to decrease. So that's why option B is not the right one. Okay, the field of view expands. No. Okay. What was field of view? What was another word for is okay, field of view? Our field of view is going to, okay, represent what? Yes,
Is it-
ladies.
Is it like when you zoom in on a picture?
No. That's not what it is, my dear. What is field of view?
Is it the sector size?
Yeah. Clear. But that is not going to, yes, okay, be related to, yes, okay, your pixel density. Okay, there are more shades of gray. No, that was not due to, yes, okay, the pixel density. That would be the case if I increase the number of bits. Then, okay, that would be, yes, okay, more shades of gray. Question number 446. And goes, if you look at 446 and 444, they may look alike to begin with. But again, yes, okay, we still have, okay, as two systems. We have system A, and again, yes, okay, we have system B. Now, system A has, okay, again, yes, okay, has 1 million pixels in an image which is 100 square inch. System B has, okay, yes, image size which is 10 square inches.
and it's composed of 250,000 pixels. Now, which image is more likely as to display very small details? Well, could I be more specific? Yeah, because the question says you would have greater pixel density. Now, for system A, girls, your pixel density is going to be as that 1 million divided by 100. Whereas for system B, it's going to be as that 25 or 250,000 divided by 10. What I mean is tell you as which system has the greatest pixel density. Because here is our image was 100 square inches. That means we're going to be 100 inches this way and 100 inches this way. In which we have has 1 million pixels. Where here is we have a smaller image. It was just 10 inches by 10 inches. But in this 10 inches, we have a total of 250,000 pixels. So you can say it's 1 million divided by 100. Turns out to just 10,000. So this is our pixel density. In this case here. Whereas as for system B, our pixel density ends up as 25,000. Everybody can say that's 25,000 is greater than 10,000. So here's the system B that has the greatest. I guess we show images with the greatest detail. Did that make sense?
Yes.
Yeah. Okay. They could even have given us as information such as you can say bits. Even if this was being 100 bits. And this would have been 10 bits. But that was not what they asked about. Okay. Always in that case, that's should be specific which kind of detail is it that they're talking about. Spatial resolution or temporal, contrast resolution. Okay. Because had they say it's best contrast resolution. Then here with me it says 1,000 bits per pixel. With 1 million pixels. Okay. That'll be greater spatial contrast resolution. Okay, what is the smallest part of a digital picture called? And ladies, that is right off the book. Pixel. Yeah, it would have been bit had they asked about digital data or digital number. Did that make sense? But the smallest unit of, okay, yes, of a digital picture is a pixel. Question number 448. The greater number of bits assigned to each pixel of a digital image, the greater the number of shades of gray does that image have. And that's yes, that's true. Very many, that's okay, just calculated that by 2 raised to the power n. Where we say it's okay, the greater this number of n here, it's okay, greater will be, it's okay, the gray shades, or we can say it's okay, greater the grayscale. And greater grayscale will mainly mean better contrast resolution. But greater number of bits will also mean, yes, okay, lesser contrast. Clear? Okay. Now, what is the smallest amount of digital storage called? And that was what we call it, okay, a bit. Okay. Do you guys remember what bit stands for? Binary digit. Well, okay, yes, this pi here actually is okay. Well, because I mean, it's okay, just as it's okay, made up of 2 digits, zeros and ones. Okay, so whenever you find it's okay, write something. Let's say it's okay. This here is actually it's okay 1 byte because we have 8 bits. Clear? But me, yes, okay, it's going to be made up of okay as a series of 8 bits. Where 0 is a bit, 0 is a bit, 1 is a bit, 0 is a bit, 1 is a bit, 1 is a bit, 1 is a bit, 0 is a bit. So mainly because okay, here we actually have okay as 8 bits. It becomes 1 byte. Did that make sense? Did you guys get that?
Yes.
Now, which of these is a binary number? Now, just keep in mind, girls, that's okay, that any number is okay made up of zeros and ones. Nowadays, okay, if you read this, okay, as an analog number, it might be as okay, whatever, zillion, billion. Okay, but it is just okay. In this case, it's okay, it's okay, going to be a binary number mainly because it's mainly it's okay, just made up of zeros and ones. Okay, yeah, E is not all the okay, it's only made up of 2 kind of digits, but there is no yes, okay, there's 1 and 2's. Clear? Okay, but 1 okay is a binary digit, but 2 is not. So that's why okay, option A is not a binary number. C is of course not, because you go from 9 to 2. And D is as okay, it could have been yes, okay, at the last digit 2. Being okay, either a 1 or a 0. Did that make sense? Did that make sense?
Yes.
Question number 451. Okay, yes, okay, we have 2 scan converters. Okay, good. So we can guess that's okay. Then we have system A and we have system B. Now system A again is okay, has okay, yes, 1 million pixels. And 4 bits assigned each. Yeah. Where system B has okay, has the same 250,000 pixels. And 12 bits per pixel. Now this system is most likely going to display images with very subtle differences in the grayscale. Does anybody who know what the word subtle means? Yes, girls. Does anybody know what subtle means?
No,
Is it, can it be like preferable?
No.
you said the
Here
word
we
is
go.
subtle, right?
Huh?
You said the word is subtle?
Yep. It's written in your book as S-U-B-T-L-E.
Maybe like a substitute?
No. So how are you going to answer the question if you don't know what it's asking about?
Isn't it like softly?
No. Less. That's the easiest way to just okay explain it. But what is that they're asking about? It's okay. It's subtle differences in the grayscale. So less difference in the grayscale. Which we mainly as okay just so far has okay translated as less contrast. Right? Or we could say better contrast resolution. And what was going to determine is, okay, a better contrast resolution? You can mean it says, okay, just a greater number of bits or pixels. Did that make sense? So that would be this one here. Or it's okay, pretty much okay due to this. Because each pixel had 12 bits. Whereas, okay, here each pixel only had 4 bits. Okay. Where 4 bits was going to be as, okay, what? 2 raised to the power 4 would mainly mean 2 multiplied by 2 multiplied by 2 multiplied by 2. If you consider, okay, 2 times 2 is 4 times 2 is 8 times 2 is 16. So here's, okay, our gray shade or grayscale had 16 sheets. You can go on, okay, do the 2 yes, okay, thing with times 12 here. It's going to be, yes, okay, some crazy number. Where you can actually say, okay, being because, okay, of this number here is, okay, being far, far greater than 2. This is going to, yes, okay, have a crazy great grayscale. As we said, okay, the difference between the shades of gray from, yes, okay, black to white here is going to, yes, okay, that are going to be, yes, okay, at a lesser difference. Did that make sense? Bareheaded asked, otherwise it says, okay, greater difference in the grayscale. It would have been system A because of a lower grayscale. That actually is, okay, that would be okay, a greater difference. As a matter of fact, it's okay, this system here will have has a poor contrast resolution. Did you ladies get that?
Yes.
Okay, go, just excuse me for a sec. I'll be right back.
Okay, girls, sorry. Okay, let's see if we can continue. Now question 452. Now that says, okay, a byte. That's okay, as how many bits? And the next is a word is how many bytes. So a byte that is going to be, it's okay, 8 bits, and a word is going to be 2 bytes. Or if it had said bit, then it would have been 16 bits. Question number 453. Now greater number of pixels. Oh, sorry. Greater number of bits per pixel. Will that lead to a better spatial resolution? No. Contrast, okay, will lead to, yes, okay, a better contrast resolution. Or will lead to a better spatial resolution. We're happy because that's okay, a greater number of pixels per, yes, okay, square inch. Because that will mainly mean, okay, as a bigger pixel density, which will lead to, yes, okay, a greater spatial resolution. Or this greater number of pixels per square inch could also mean, yes, okay, a smaller pixel size. Or okay, that will lead to, yes, okay, greater spatial result of pixel density, which also, yes, okay, will lead to a better spatial resolution. Well, as far as goes the number of bits per pixel is concerned, that will determine, yes, okay, the contrast resolution. Or we can say, yes, okay, this number of bits here, yes, okay, will determine, yes, okay, the number of sheets of gray. On, yes, okay, the grayscale. Which will determine, yes, okay, whether we have a good or a bad contrast resolution. Did you girls get that? Did you girls get that?
Yes.
Good. Now, what happens to an image when the number of bits allowed to each pixel increases? Now your spatial resolution is not going to just improve. That will only improve is as the number of pixels per image. Or a square inch will just increase. Frame rate increases. No, hell no. Like I said, that's pretty much going to be just related to that. Field of view expands. That's your sector size. That had nothing to do with the number of bits per pixel. Clear? They're not going to be related. So the only thing that's going to happen is that as with more bits per pixel, this number of shades of gray will increase. And with that number of shades of gray, lesser contrast, but better contrast resolution. Did you really get that? Okay, 455. Now, what are the maximum number of shades of gray that are represented by 4 bits? Which means now the number of shades of gray that 4 bits may represent is going to be 2 raised to the power n. And this number here is n. Which means root 2 raised to the power 4, which means 2 times 2 times 2 times 2. En nou 2 gang 4 over 16. 16. So 4 bits per pixel can give you up to 16 shades of gray per pixel. Did that make sense? That's 456 meters. Just asked the very same thing. Just by as a different number of bits, which is 6 bits. Where you mean you says that will become 2 raised to power n when this is n, which will mean 2 raised to power 6, which means 2 times 2 times 2 times 2 6. So that become 4, 8, 16, 32, 64. So 64 bits, 64 shades of gray per pixel. If each pixel add up to 6 bits. Did that make sense? Now, in the next question, pretty much the same kind of information is being asked. But here's they're asking about 3 different sheets. If we have 10 sheets, if we have 14 sheets, and if we, for instance, had 15 sheets. Now, what we already know is from this question here, that 4 bits could represent up to 16 sheets. We can just say what would have been a number of sheets for, let's say, 3 bits. That means 2 times 2 times 2. Which would have been a total of 8 sheets. So that's going to be too low. But as long as we had 4 bits that could represent, okay, as 10 sheets, 14 sheets, 15 sheets. It could even as okay represent as okay 9 sheets. Would still be as okay 4 bits. 11 sheets, 12 sheets, 13 sheets would still have been as okay 4 bits. Whereas 3 bits can only as okay represent up to 8 sheets. Or we can say okay anything between it's okay 8 or it's okay 5 to 8 sheets. Because 2 bits would have been as okay up to 4 sheets. Did that make sense? So this formula is okay here, is okay, which is 2 raised to the power n. Made as okay is going to as okay. Okay, oh, it's okay. What this formula equation is going to give us is because it's okay the maximum number of sheets that okay is the number of bits per pixel will be able to just okay display. Clear? At this for instance, okay, said 17 sheets and not 14. Then it might be yes, okay, 10 for this one here, 10 for this one here, but it's okay for the 15 or 17 sheets. Because it's okay, that might be 5 sheets. Because now 5 sheets means it's okay for me, it's okay, that will be able to just okay display up to yes, okay, 10 multiplied by 5, which would have been 2 times 2 times 2 times 2 times 2, which become 4, 8, 16, 32. So 5 bits can display anything from yes, okay, 16 sheets to 32 sheets. Okay, yes, 17 sheets fall under that range if you want to put it that way. Did you guys get that? Well, okay, page is okay. Answering that, we actually already answered. It's okay. The next question as well, because it says what's going to be the number of binary digits. Now, yes, okay. Here, just keep in mind, girl, that okay, as you were. Binary digits mean that's okay. What to mean is okay. It just means by bits. Clear? Required to store as okay 29 levels of gray. So it's okay. We are talking about 29. Well, okay, levels of gray. Well, okay, this levels of gray mean it's okay. It just means the same as sheets of gray. Which from the previous question said, well, I calculated was okay as 2 raised to the power 5, which made it up to okay 32 squares or 32 sheets. Clear? So it's okay 5 bits per pixel. Yes, okay, can display up to okay 29 sheets or maximum yes, okay 32. So when you go from 32 and above, yes, okay, you can say I said, and it said okay at 33 sheets, then it would have been 6 bits. Now this 6 bits is going to just okay go from 33 to 64. Where 64 then will be the maximum. Did that make sense? Okay, 459. Okay, so true or false. So for digital image information to be displayed on a conventional television screen, the data must be processed by a digital to analog scan converter. And that was true. That means that's okay what we saw on that figure in your book. But we say, okay, yes. Now we said, okay, the memory, yes, okay, that was digital. But that's okay, it has to, yes, okay, be displayed on an analog. It is okay within this place in this question. I mean, it's okay, just ask. It's okay, phrase as okay as a conventional television. But this digital information here is okay, first has to be converted into an analog in that form of data through as okay digital to analog scan converter. So yes, okay, digital image formation or data from this system here gotta be converted into an analog format so it can be displayed on this analog or what they say is okay, conventional television or conventional display. Did that make sense? Yes. And we can mean yes, okay, just say that okay, yes, all this will be as okay post-processing. $460. Again, yes, true or false. So pre-process of image data occurs after the data has been stored in a scan converter. And that was false. It's actually that's okay obvious from the word. Pre means before. So pre-processing was okay, I'd been through as I said before, stored on that's okay, most likely it's okay in the memory. So post-processing SOK of image data occurs after the data has been stored in a scan converter. Yes, because post means after. He also said, okay, yes, that pre-processing was not reversible, whereas post-processing is okay was reversible. Pre-processing or non-reversible is okay. Magnification was what we called read. Oh, sorry, write, sorry. And post was, which was reversible. And okay, we said magnification was read magnification. Question 462. Now, all of the following are true of read zoom, except, now what did we say that a read zoom was? Okay, my girls, it was okay. That's an example of post-processing. Now, since it was post-processing, yes, okay, it was reversible. Okay, now let's see. Pre-processing functioning of the receiver. That's not true. So that's okay. Here we have the option. Because okay, read zoom was post-processing. It was not pre-processing. Okay. Now the same number of pixels are in the original region of interest and that are zoomed in image. Please remember that. Which mainly mean that okay, yes, this was your original image. And it was not zoomed in. It might have, let's say, it's okay, 1000 pixels by 1000 pixels. Where we can say it's okay, this here is okay, was your region of interest. But then it's okay when you zoom in on this region of interest here. Now the main thing that just happens is okay, that okay, your region of interest occupies this. Whereas okay, the pixel density is still going to be as 1000 by 1000. Did that make sense? Yep. Now it's option C on the screen. The pixels of the zoomed image are larger than those in the region of interest. Yes. These pixels here becomes larger. The same number of ultrasound pulses are used to create the original image, original region of interest, and the zoom image. Yes, because as we said here, this is equal to this is equal to this. Did that make sense? Right. Well, what mainly happens here is that okay, as in the read zoomed image, there will be a degraded spatial resolution, mainly because of okay, the increased pixel size. Of yes, okay, the object in your region of interest. If that makes sense. Now it's pretty much okay. It's the same thing that they ask in the following question, but about right zoom or right magnification. And we already know that, okay, this is okay as an example of pre-process. Clear. We also said, okay, this was, because being as okay an example, pre-processing was not reversible. Clear? Okay. Now pre-processing function of the company is okay, transducer. That is true. Now the same number of pixels are in the region of, or in the original region of interest and in the zoom in image. That's false. Because, okay, if this was our original image, we can say it's okay if it was 1,000 pixels by 1,000 pixels. But it's okay if this here is okay is our region of interest. This boundary is okay here just constitute of okay 10 by 10. Here, where okay as when we zoom in on that, now this zoomed in image here is going to choose okay be this. Here's okay the region of interest was 10 by 10 pixels, for instance. Here becomes just okay 1,000 by 1,000. So comparing as okay, this pixel density to this are not the same. The pixel density of the whole image to the whole image is the same. Did that make sense? Did you guys get that?
Yes.
And that's why we also says okay, may says okay in right zooming. Well, okay, yes. That is going to be as okay, actually is okay, because that improved spatial resolution. Because now this region here is okay, which one means is okay, just 10 by 10 pixels on the original image actually going to be as okay. On a display by okay 1,000 pixels by 1,000 pixels. Okay, says okay 1,000 pixels by pixel density of 1,000 pixels. Okay, girls. Now, just take a short break. Should we say that I see you ladies back at 11 o'clock? Is that fair?
Yes.
Okay, thank you, that's it.
Um, any questions? Nope. No questions? There goes. Then I guess we can maybe it's okay go on to the next chapter, which will be as okay chapter 16. Which is going to be as okay what we can call as okay dynamic range. It's mainly as okay is going to as okay we can say as okay be further as okay related to what we call compression. Is that clear? Is that clear, girls?
Yes.
Okay. And with this compression here is okay as the last thing that we will talk about is going to is okay be we can say it's okay related to is okay where will be is okay the number of choices. What do you mean by the number of choices going to is okay be the number of choices of sheets of gray. Okay, girls. Now the main is okay, just a couple of things is okay for this. What do you want to call it? Is okay chapter here that you will need to remember. Now, girls, whenever you see the word range, what we actually is okay will mean by as okay a range is that okay as that's going to be as okay we can mean it says okay the difference. Oh, let me just write it as we can say it's range. That means okay going to be as okay the difference between what we in this case says okay we can say okay one will be as okay one will be the maximum, and at the other end of the range is going to be as okay a minimum. We can say it's okay maximum value and okay as minimum value. Is that clear? Now, as far as the dynamic range is concerned, it's okay what they mean. It's okay just says okay whatever is going to be as okay the maximum value of the range is going to be referred to as a is going to be called a saturation. Is that clear?
It's going to be called, I'm sorry, can you say it's going to be called what again?
Saturation.
Thank you.
Okay, mainly says okay once the maximum capacity of the class has been met, right? Okay. Let's say okay as we are able to just okay have no more than let's okay 20 students per class. Once that maximum is met, that may mean that okay as the class is saturated to its maximum, right? Did that make sense? Which mainly would mean that okay as no class
roughly speaking, is okay. There will not be as okay 21 students per class. There's not going to be as okay 22 students or 30 students per class. Mainly because the max value of students in class, or we can say, okay, where this class means, okay, going to be as okay, saturated to its max, or have reached the saturation, was 20. Did that make sense? So the maximum value on your okay dynamic range is going to be okay, what is going to be referred to as a saturation. Where okay, the minimum value on the range, that is going to be okay, what we refer to as a threshold. Is that clear? Did that make sense?
Yes.
Right, okay. Where we then mainly can say is okay that the difference, or let me just put one little other thing. Because okay, what do we call anything that is going to be considered okay, that's going to be less than the, that's okay, what we is okay call the threshold. That's okay, less than the minimum value. That is going to be as okay, what we refer to as noise. But that's okay. Practically, as okay on our scale, what did we have? We had two values. We had a maximum value, we had a minimum value. And what anything is okay that was going to is okay be less than the minimum is going to be noise. Did that make sense?
Yes.
Okay. Now the reason that we call it dynamic is okay, we're going to come to that in just a little bit. But you guys as okay should know what the word dynamic meant. That means okay going to be as okay something which is not constant. I mean that because it's not constant, that's what I'm gonna mean it's okay that it will change. But in this case, if you can say it's okay, your dynamic range, or you will have okay, it's a great dynamic range. If, for instance, okay, you have a great difference between your saturation, which was the maximum value, sorry, and that's okay, your threshold, which was the minimum value. Clear? So the greater the difference between, yes, okay, these two values here, you can mean this as okay, that will be as okay, a greater dynamic range. Whereas, okay, yes, on the other hand, you could say that, okay, yes, a lower dynamic range is going to be as okay, a lesser difference between what was okay, the same. We can say as okay, the saturation and your threshold.
Did you get that? There's an example you can say, it's okay, if for instance, okay, the maximum value was 1,000. And your minimum value was, let's say, it's okay, 1. You could say, okay, there will be a great difference between 1,000 and 1. Compared to, it's okay, if we had a lesser difference where, okay, as you could say, the maximum value was, let's say, it's okay, still 1,000. But where your minimum value would have been, let's say, it's okay, 100. Clear? Where, okay, so in this case, it's okay, there was going to be, it's okay, a lesser dynamic range. Because of a lesser difference between the maximum and minimum. Compared to, it's okay, when it was 1,000 and 1. Did that make sense? Did that make sense?
Yeah.
Right. Okay. Or you could say, yes, okay, you started your day with $1,000. You ended your day with just $1. When you compare, yes, okay, your balance of money that you had at the beginning of the day to the amount of money that you had at the day, you can mainly say, okay, that okay, as what you're left with now is 1,000. Yeah, okay, if you can just compare, yes, okay, the same, you do the same comparison here. So, okay, yes, you start your day with $1,000, but you ended up with $100. So, but were you still, okay, yes, you still, okay, now 1/10 at the end of the day compared to, yes, okay, what you started with the day. Clear? Okay.
I have
So
a
mainly
quick
because, just a sec. Mainly because you can say, okay, it's comparing, it's okay, what you started with to what you ended with, or what you started with to what you ended with. Or you can say, okay, the maximum be compared to the minimum. The maximum compared to the minimum. Well, okay, goes the unit for your dynamic range is going to be decibels. Just as, okay, if you go back and look in chapter 14 and look at, okay, yes, your compression, the unit for that was decibels. Or it's going to be actually expressed in the unit of decibels. Is that clear?
yes.
Okay. Now, ladies, whenever you turn the system on, whenever, yes, okay, you turn the system on, you may, yes, okay, to find that, okay, yes, the dynamic range is always going to, yes, okay, be expressed as, okay, 74%. Okay. So you can maybe says, okay, here the range. Greater difference will be, yes, okay, a greater range of choices. Let's put it this way, it says, okay, greater difference between maximum and minimum. Mainly, it's okay, will be a greater number of choices.
Whereas, okay, yes, on the other hand, lesser range is going to be, yes, okay, a lesser difference between, yes, okay, the saturation and threshold, which means, okay, will become, okay, as a lesser number of choices. What we mean by the number of choices is going to be, yes, okay, of shades of gray. And of shades of gray. So that was your range. Is that clear?
Yes.
Now, yes, okay, we're going to come to the factor, yes, okay, the y and the, do we call it, yes, okay, dynamic. Why do we call it a dynamic? Now, girls, what I will do is I will recommend all of you to look at table 16.1. Now you'll find is okay, page 266. Does everybody have their books?
Yes.
Good. Are you able to open it on page 266?
Yeah.
Good. And what do you see? You see a table, right?
Yep.
Good. Now, ladies, it gives you, yes, okay, two information. It gives you components and it gives you, yes, okay, the dynamic range. Now, ladies, if you follow the list of components, on the first one, which is, okay, yes, your transducer. To the next one, which is one, yes, okay, which is your receiver. To the next one, which is okay, is going to be, yes, okay, because it's your scan converters. To the next one, which is okay, is your display. To the last one, which is going to be as okay, what you can call as okay, the archive. Here. Now this information, or this sequence here is okay, is evaluable in two ways. Mainly because okay, what we see in this case is okay, as we go from transducer, which means okay, has the greatest dynamic range. And we go yes, okay, to the archive, which is going to have okay, the lowest dynamic range. What does that tell you? That okay, as you go in this direction here, this is going to be okay, your dynamic range in a what is going to okay, a decreasing order. Whereas okay, if we had gone in the opposite direction, like this would just have been yes, okay, your dynamic range in an increasing order, right? Is
Right.
that clear?
Yep.
Good. Okay. Now you also yes, okay, look at this sequence here and compare that to yes, okay, that diagram that we had in chapter 15. And let me just see if I can look at this. Which one was it? Figure 15.7. And what did I say? Well, okay, yes, we started at the transducer. Now all this, okay, 15.7. Doesn't give you, yes, okay, your receiver, but it says, okay, your receiver is going to be here in the processing. I mean, yes, okay, we are going to say that because, okay, we talked about it, okay, then in chapter 14. So we are already, yes, okay, done with this. The transducer we already, yes, okay, talked about in, okay, with respect to chapter 8 and chapter 12. Right. But what we actually is, okay, said in chapter 14, or it's okay, 15, was that, okay, your transducer was analog. But then, yes, okay, it goes to the receiver. From the receiver, yes, okay, it went on to, yes, okay, our first scan converter. With all the, yes, okay, was, you can say it's okay, analog to digital. Out of which, okay, they really don't talk about, yes, okay, the memory, but we can say, okay, the memory have been here. And, okay, all the panel values, okay, or display. We might have had, okay, as another scan converter. Or we might just, okay, have a directly display. And last but not the least, the going to just, okay, be your archive. Very many can say it's okay that these files are being stored. Did that make sense? Did that make sense?
Yes.
Okay. Now, one thing that I said about is, okay, when we said that the transducer always is going to be analog. Was me, it's okay because it's okay because we said, okay, that it was limitless. Or we can say unlimited. Which mainly will mean here that, okay, yes, the transducer is going to just, okay, have the greatest dynamic range. Which mainly will mean that, okay, there will be, it's okay, a greater difference between the maximum and minimum. Maximum what and minimum what? Yes, okay, shades of grays. So you can mainly say, okay, that your transducer is going to be as okay, or the data processed by as okay, or as okay, received by the transducer is going to be analog. Mainly because it's going to have as okay, the greatest number of, or the greatest dynamic range. Or as we may say, as okay, here, the transducer means it's okay, going to be the component of all yes, okay, ultrasound components, which is going to yes, okay, have the greatest varieties of shades of gray. We can say as okay, varieties of shades in hundreds and thousands. The variety of shades may be in hundreds or thousands. Did that make sense? Did that make sense, girls?
Yes, it is.
Clear? Okay. Now, yes, okay. That goes to the transducer. What was it that we said that the transducer was going to do? No, sorry, not transducer, sorry. Receiver. Compress. Okay. Now, what the compression mean is going to be meaning is okay, that we can say it's okay. The more than yes, okay, signal is going to be compressed. that will actually lead to, yes, okay, a lesser grayscale. Well, okay, we could just have said that's okay if we had, okay, yes, a lesser compression. Well, after the compression is okay, there will be, as okay, it's still a greater scale. But whatever the case is, both of these grayscale here, let's say a smaller grayscale or a lesser grayscale, as a result of, okay, a greater compression or lesser compression, is still going to, yes, okay, be lesser than, okay, as because there's a grayscale of the shades of gray received by the transducer. Did that make sense?
Yes.
Okay. Now, some of you may be scratching your heads and said, well, why do we need to reduce the varieties of gray shades? Because, okay, hundreds of shades or maybe even thousands of shades of gray is going to be, as okay, overwhelming for your eyes. It's going to be as okay that you can say that, okay, good was good. Grayscale was good. But too much good is bad, which means to me as okay, too great of a grayscale will be bad. Did that make sense? Okay, but even now, here's a thing that is going to be important. Okay, even though yes, okay, the grayscale is compressed, which you mainly will see yes, okay, that the dynamic range will decrease. But the strongest signal is still going to be the brightest. Or we can say, okay, the maximum signal is still going to be the brightest, and the weakest signal is still going to be the darkest. Did that make sense?
Yeah.
Right, okay. But where you mean you can say is okay, that okay, the varieties of shades of gray in this case is okay, mean it's okay, that's going to be reduced.
So our
Okay, so that's pretty much okay, ladies, what is going to happen to the grayscale as it goes from transducer to receiver, from receiver to the scan converters, from the scan converters to the arc display. Now, when you say display, what does that mean? Because that could be your monitor. If some of you is okay, say, what the do you mean by monitor? Well, okay, girls. That could be your screen. So this screen here is okay, mainly as okay, is only going to as okay show as okay the number of shades of gray. That is going to be as okay, just enough for the eyes to as okay to be able to detect at a time. Clear? Did that make sense? So you can mainly say, okay, what happens by as okay, you can say it's okay, compression. The more the image is compressed, lesser will be as okay your dynamic range.
I have a question.
That's a segment here. Lesser the dynamic range, that's okay, lesser the grayscale. Clear? Okay, yes, Dr. King.
So lesser the dynamic range, would that Would that help the contrast or would it not help the contrast?
Well, okay, you're not going to just, okay, compress it so much that you only get bistable, right?
Yeah.
Clear? Okay. But just as I said, that, okay, yes, what your transducer does. So that's why I say, yes, okay, please remember that, okay, yes, analog meant unlimited. Now, probably not unlimited, but at least you can say, yes, okay, yes, your transducer was all going to be analog, mainly because, okay, what it would do is, okay, it will receive, let's say, yes, okay, you can say, yes, okay, up to, yes, okay, 1 million different types of sheets of gray. Did that make sense?
Yeah.
Okay. Now, if you just say, well, okay, yes, 1 million types of shades of gray, that will mainly mean that, okay, yes, each pixel on your image was going to just, okay, have, okay, as a, yes, okay, use a crazy number of bits. Did that make sense?
Yeah.
Right. Okay. Now, just look at it in this way, my dear. The more bits that needs to be processed, well, okay, it will take a longer time. It may be a machine, it may be a computer, it may be, yes, okay, whatever you call it. But if it's going to, okay, the more bits it needs to process for, yes, okay, to display any object or anything, it will take more time.
Yeah.
Okay. Now, it may have been before your day, yes, okay, your living time, but yes, okay, if a file that you received, yes, okay, on the internet in an email or so as an attachment was big, you might actually, yes, okay, had to sit there and wait for it to just, okay, upload.
Oh.
Okay. This is not something that we experience that often nowadays, mainly because why? Well, okay, as the internet is more faster than it was back then. So, okay, you could receive a big file, but that big file is okay, may take, yes, okay, maybe as okay, 45 minutes to open. Did that make sense?
Yes.
Clear? So maybe as okay, what they just did for that was just okay, they introduced what they call zip files. And what was it that a zip file actually would do? Compress it. So it became smaller in size. Or we can say, okay, actually it's okay, were lesser bits. But the strongest signal is okay, we can say the maximum of the saturation was still the same. The threshold was still going to be the same. But there's just going to be okay, a lesser variety of a smaller range. Or that's okay, we can say okay, shades of gray. Okay, so that was me. Yes, okay, what's going to happen? Yes, okay, when you unzipped it, that regress, okay, came back into the original form. Because that's okay, you uncompressed it by unzipping it. So you may have received, okay, as a file which was, okay, only 2 kilobytes in a zip format. Or you can say, okay, compressed. But when you unzip it or you uncompress it, it goes from, yes, okay, 2 kilobytes to 2 megabytes. Probably not that extreme, but like, okay, you can pretty much put it that way. Clear? Okay. So for the computer screen or for your display, yes, okay, good is good, but too much good becomes bad.
Okay.
Did that make sense?
Yes.
So you don't really need to see as okay, you can say as okay, 1 million varieties of shades of gray. That is too much. So what the system actually does is, yes, okay, the signal travels, it's going to get more and more and more compressed. Did that make sense? Okay, so this table 15 point, oh, sorry, 15 point, 16.1. Maybe that's okay, give you that's okay the information about two things. First of all, that's okay if we start from here to here. We can actually say, okay, that's going to be, okay, your dynamic range in a decreasing order. Did that make sense?
Yeah.
Another thing that it also tells you is, okay, what are the components of your system? Because, okay, what is the sequence of the components of your system through which, yes, okay, the signal is being processed. So we should know by now, yes, okay, the first component that's going to just, okay, receive sound waves will be your transducer. That transducer may, yes, okay, just convert those sound waves into electrical waves. We will send to the receiver. Receiver has, okay, had those 5 major functions, right? Amplification, compression, compensation, demodulation, and reject. After which it will go, yes, okay, to the scan converters. We know that, okay, from the scan converters, that's okay, we'll go to the memory. From memory, that's okay, to display. And okay, last but not the least is going to be, okay, the archive. That can mean it's okay, that says, okay, that they'll be stored. Did that make sense?
Yes, it did.
So this sequence here, yes, okay, goes, that is a much to remember. Okay. As far as, okay, the dynamic range for each of them, that's the transducer, the receiver, the converters, the display, and or it's okay, your archive. It's okay, those values you don't need to remember. Okay, so you're not going to be asked, okay, what is the typical dynamic range of the receiver? What is the typical value of the dynamic range of, let's say, it's okay, the display, so and so. Is that clear? But the sequence here is important. Just as we said for us, okay, for your impedance. Right, okay? Just as we said for the impedance. But you didn't have to remember, it's okay, the impedances for each component. Backing material, matching layer, PCT, gel, skin, PPP. Okay, but the sequence was important. But here, it's okay, this sequence here is okay, tells you two things. Yes, okay, the range of your dynamic range from highest to lowest. Did that make sense?
Yeah.
And we can also say, okay, it also tells you, okay, after transducer, where does the signal go? After receiver, yes, okay, where does the signal go? After that, yes, okay, where does the signal go? Where does it go? Like this. So it's okay, this is a 2-in-1. But the whole thing is that, okay, yes, from the beginning, we can say, okay, the transducer is okay, we have a greatest dynamic range. Just give me a second. Just give me a second.
Okay, sorry, girls. Okay. Did that make sense? Okay. Now, girls, look here. We can now we can make yes, okay, just put the information and say yes, okay. We say yes, okay, we have a great dynamic range. What did that great dynamic range? That mainly meant okay, yes,
Trouble?
a great difference
Daniel?
between the maximum, which we will call the saturation, and okay, as the threshold. Or we can say okay, the minimum, which we call the threshold. Clear? Okay, and what this greater difference here is okay would mean was it's okay, we're going to use a greater dynamic range, which means it's okay means greater. It's okay. Choices of great. A greater number of choices. Right, okay. Which okay as would be as okay, greater number of choices of gray. Or we could say as okay, greater grayscale. Now this greater dynamic range or greater difference between maximum and minimum. Or greater is okay, choice of gray or greater grayscale is less compression. Did that make sense? Did that make sense, girls?
Yes.
Okay, whereas if you just go the other way, okay, sorry. Yes, okay, in the other direction, I say yes, okay. A smaller dynamic range. What I mean? That means yes, okay, that we had a lesser difference between yes, okay, what we call the maximum. Which okay, as far as the range was concerned, that was mainly as okay, what we refer to as the saturation. And that's okay, our minimum. Okay, this minimum here is okay, what's going to be called the threshold. Or we may can say it's okay that this smaller dynamic range, a lesser difference between the minimum and maximum, maybe it's okay meant a lesser number of choices of gray. Which means it's okay with me, it's okay a smaller grayscale. And that means it's okay be as a result of more compression. Did that make sense?
Yeah.
Right, okay. Well, when we say yes, okay, this comparison between this and this
Well, it's okay, the comparison between this and this was going to is okay be expressed by the units of decibels. But we may say that's okay. We started with that's okay, million shades of gray. But and that okay, yes, 100 shades of gray. That will be as okay, greater compression compared to as okay. We still started with a million shades of gray, but end up with okay as 100,000 shades of gray. Because that's going to be a lesser compression, lesser decibels. Did that make sense? Okay, go. So ultimately, yes, okay. You can say, okay, this here is okay. That is the main, yes, okay, summary of your chapter. Maybe if I just can go on and say it's okay. Let's just do this fancy, it's okay. Lowest dynamic range. What that mean? Okay, that mean that we have okay the lowest difference between yes, okay, the maximum, which was your saturation, and the minimum. But we mean, like I said, it's okay, there's lowest difference here. It's okay, what mainly just mean the lowest or the smallest grayscale. And that smallest grayscale as okay could only have as okay 2 sheets, which we're going to use okay be bistable. Did you ladies get that? Did you ladies get that?
Yes.
Okay. Or just okay. I don't like to give you okay examples of okay as grades and tests, but anyways, we can see it's okay. If you go for then it's okay the numbers, or we can say it's okay the percentages that are scored on a test. Somebody can get as okay as high as 100%. God forbid somebody gets me as okay, even get as low as okay as 0%. If that makes sense. Which mainly we say okay here between it's okay, you can get 99, you can get 98. Yes, okay, there are going to be okay 100 different varieties of percentages that could be given. Okay, many as okay will say that okay, yes, this here was still going to be as okay the saturation. We can see as okay, this one here will still yes okay be yes okay. We can say okay, your threshold at least for now. Okay, but your percentages could be given as okay as you got 100%, you got 99%, you got 98%, 97, 96, so on, so on, so on until 0%. So there's 100 different varieties of percentages.
Whereas we may say about, okay, any less is okay percentage that go from is okay from 100 to 90% would be A. We can say it's okay from 89% to 80 would be B. Because it's okay from 80% to let's say 70 would be C. We can say it's okay, anything is okay from us okay as, oh sorry, 79 to 70. Okay, and then we go as okay, 69 to 60 would be D. Let's just say that okay, this here is okay as our new threshold, because anything less than that would be as okay just because it's okay failure. So because it's okay 59% and below. Okay, we can say okay, it will be F or failure, or because it's okay noise, which we want to, it's okay, eliminate. But even if we are going on and says, okay, yes, for each 10%, it became a letter. Be compressed. Did that make sense? Did that make sense?
Yes.
Clear? Okay. But we can say as okay. Now then we can go in A's and say as okay. 100% will be A plus. 99 to let's say it's okay, 96 would just have been plain A. And then it's okay from 96 to 90 would have been A minus. Then we go B. Will be plus. From this to yes, okay. 86% would have been plain B. Yes, okay. From 86 to 80 would be a B negative. Something like that. Okay. So when we go as okay in plus planes and negatives, plus planes and negatives, we still have okay as a greater dynamic range. Because we have okay as a greater choices of different kinds of A's. You could be an A plus student, you could just have been an A, or you could have been an A minus. Whereas if you go from as okay A plus, A and A minus to just A. Wow, okay, yes. The range of A is okay is less specific. Because okay, the choice that comes with an A is going to be as okay greater. So you can mean as okay, just say as okay. This could have be as okay the brightest. This will be as okay less bright. This will be as okay less bright. And so on. And I say as okay, we manage as okay, reach the minimum brightness or brilliance. Anything below that was going to it's okay, be noise. So what is okay compression does, it will say as okay, you can say as okay, show as okay the brightest or the strongest intensity reflections as the brightest ones. The one that are lesser is going to as okay be darker. Lesser bright, even more dark. Lesser bright, even more dark, and not at least bright. But here we could say, okay, we had 100 different shades of possibilities from the darkest or from the brightest to the darkest.
that becomes less specific. Or we are left with lesser choices. Did you girls get that? Okay, so where is everyone? You can say, okay, the most compression. Maybe it's okay the display, at least for us, okay, for the eyes too, yes, okay, be able to consider clearly. Not clearly, it's okay, but actually, it's okay. Look at that image and okay, yes, still make it okay, as give us okay as the relevant information that we need. You don't want to compress it too much because you may end up as just okay 2 sheets bistable. Okay, so it's all a matter of you can say okay fine tuning. So that's okay. We have different yes okay what we is okay for now we call is okay gray maps, which are mainly as okay just as okay different maps of okay so okay different varieties of dynamic ranges. Okay, some maps will have okay a lot of bright and less dark varieties and so on. But it's mainly that's okay a matter of you can say okay fine tuning. Just to just okay achieve that Goldilocks effect. Because okay this image looks great. Okay, it's not too many varieties, but not too less. So that's how yes okay we are actually able to yes okay adjust the compression. Any questions? So if you yes okay say okay yes let us okay yes summarize yes okay this whole chapter here into yes okay 1 page. This would be it.
What does it say in the yellow?
Lowest dynamic range. And what does that mean? That's going to be as okay the lowest difference between the maximum, which was your saturation, and minimum, which is your threshold, right? And what would that mean? That you have the smallest grayscale. What did we call the smallest grayscale? Where we only had 2 sheets, right? Okay, black and white. And what did we call that one? That was bistable. Did that make sense? So this page here is okay, along with okay, as table 16.1. But it's okay, just the names of the components. You don't need to remember, it's okay, the typical values. And you girls got that?
Yes.
Okay. Okay. So you're not going to be asked, okay, so what is the typical dynamic range for, let's say, it's okay, a scan converter. Okay. But if you look at the number, yes, okay, it starts at okay, 120. But that means okay, it just decreases as we go from transducer to archive. So the sequence is important. Okay. So transducer, analog. Okay. To receiver, from receiver to yes, okay, scan cover, from scan cover display, from display yes, okay, archive. We can mainly say it's okay that the archive is going to just okay be storing it as okay as what I referred to earlier as a zip file. Okay. Now go just take yes okay your lunch break and it's okay when we come back it's okay we'll try to just okay do the questions. And I just okay we can say it's okay CAD. Call it a day. So should I see you ladies back at 1 o'clock? Is that fair enough?
Okay.
Okay, dear. Have fun till then. DC. Okay, girls. Welcome back. Now, any questions? Nope. Okay. So, so I would like all of you to yes, okay, go to page 267. And look at okay, yes, question number 1 to 4. Okay. So we can make yes, okay, just yes, okay, because there's a calculation of the compression. If you want to put it that way. Or okay, uncompressed image or compressed image. So in our first question here is okay, what it says, an uncompressed signal within the receiver of an ultrasound system has a dynamic range of 110 decibels. So this is the uncompressed. We can just say it's okay, signal had okay at a dynamic range of 110 decibels, right? Okay. The signal undergoes 40 decibels of compression. So the compression is of only 40 decibels. Okay. And then they made us, okay, just ask us, okay, yes, where is the dynamic range of the compressed signal? It's going to be, okay, how many decibels? Right, okay. And we made this, okay, just get that by subtracting this, okay, the compressed or compression from the uncompressed signal. And that is going to give you a total of, let's see, where were we? Okay, good. 110 subtracted of 4 subtracted from that is going to become a okay, total of 70 decibels. So here we can mean says okay that the signal is compressed by 70 decibels. Did that make sense? Let's just go on to the next question. So that's okay. Again, yes, okay. An uncompressed signal has a decibel, it also has a dynamic range of 85 decibels. So again, yes, okay, the uncompressed signal. Was 85 decibels. Now the signal undergoes just okay 30 decibels of compression. So the compression here is 30 decibels. Okay, now what is the range of the dynamic range of the compressed signal? So the compressed signal. Again, yes, okay, the same. Then we had 85 decibels. It undergoes, yes, okay, a 30 decibel compression. So it's okay, what we mean is going to be left with is going to be, it's okay, the compressed, which is going to 55 decibels. Did that make sense? Yes, girls. Did that make sense? Now, question number 3, for instance, okay, let's see what that asks us, or what it gives us. Now, after compression, a signal within the ultrasound system had a dynamic range of 70 decibels. So you can say, it's okay, this is already going to be, it's okay, the compressed signal is going to have a dynamic range of 70 decibels. Here, the original signal was compressed by 40 decibels. So we can maybe say, okay, that was going to be, it's okay, be the compression was of 40 decibels. Okay. What is the dynamic range of the original uncompressed signal? Uncompressed signal. What is what the decibels, okay, what the range was before it was compressed by 40 decibels and end up above 70. So that means, okay, there's going to be a sum of these two here. Every mean you can see that, okay, that's going to be, so a total of 111 decibels. Did you ladies get that? Yes, okay, let's go to question number 4. A signal receiver has a dynamic range of 60 decibels after compression. So we can say it's okay, again, this is going to be, it's okay, the compressed signals is 60 decibels. The signal was originally, it's okay, compressed by 50 decibels. Or the original signal was compressed by 50 decibels. So the degree of compression was 50 decibels. Okay, so I guess what to say, okay, yes. What is the original dynamic range of the original uncompressed signal? Or we can say, okay, before compression, that's just going to be the same. That 60 will be added to 50. And okay, yes, what do we have as the uncompressed signal is going to be, it's okay, 110 decibels. Did that make sense? Did that make sense?
Yes.
Okay, ladies. Now, we don't have any questions at the end of the chapter, but we have some questions at the back of the book. So we can actually, it's okay, go back to it's okay page 518. And if you look at question 464, which means it's okay, say true or false. So assignment of different shades of gray to digital lumber store and scan converter acts to improve the diagnostic value of an ultrasound exam. And that was true. Okay, although it's okay, we can say it's okay that the number of shades of gray decreases as a result of compression. Right, okay, but just keep in mind that, okay, yes, at the transducer level, that, okay, yes, that was, okay, too high of a gray scale. So we can make it, okay, too much good is bad. Did that make sense? Okay, so mainly it's okay to reduce the shades of gray. That's why we had just okay compression. Capiche? Or we can say is okay, all different components have different dynamic ranges. Now the relationship between the smallest, the largest and the smallest signal amplitude processed by components of an ultrasound system is called the dash and has a unit of dash. I just said, oh yes, okay, here is okay, what is the maximum? That was what we call saturation rate. Clear? And minimum. That was what we okay call the threshold. Okay. So the relationship between the maximum and minimum. That was related to okay, the dynamic range. So relationship between the largest and smallest signal amplitudes processed by components of an ultrasound system is called the dynamic range. And the unit that this dynamic range is, okay, it's expressed with Bose or decibel. Did you guys get that?
Yeah.
Yeah, we can say it's okay, maximum saturation, maximum of saturation, that's going to be as okay, the brightest. And then these is okay, that's going to be the darkest. And whatever was okay, it's a lesser amplitude. Intensity than the minimum.
which we call the threshold. Was nice. Okay. But it's okay because it says okay the way that this was reduced was it's okay removed from your image was actually it's okay as a function of reject. Which means it's okay just work it's okay filter out these and not try to yes okay I try not to do anything to yes okay any of these. Now if you go on to the next question girls, you can see yes okay which of these components typically has the greatest dynamic range. That's why I told you yes okay that table right okay 16.1. So yes, okay, here you mean it's okay, just have to look for the one that has the greatest dynamic range. Clear? And that will be as okay, your amplifier. Now some of you say, well, okay, what the is an amplifier? Well, okay, yes, okay, they mean yes, okay, just refer to that as okay as the receiver. Why do they call it amplifier? Mainly because one of the major functions of the receiver is amplification. Did that make sense? Okay. Which although yes, okay, however, yes, okay, dynamic range that was okay as lesser than the transducer, but we don't have the transducer in this case here. Clear? Okay, pulsar is not even involved in okay as the equation here. Okay, demodulator, well, okay, as was a function of, you can say it's okay, still a receiver, but that was going to be as okay, be performed. Or you can say demodulation was a process of the receiver carried out after amplification. Because you remember from chapter 14, the first function by us, okay, your receiver was amplification, followed by compensation, followed by compression, followed by as okay because it's okay demodulation, followed by reject. So that would mean as okay. Another reason is okay why we're actually like just okay remember them in an order. If I'm not mistaken, as okay, there was a question in the okay as your chapter 14's exam review about this sequence here. Clear? Had we had, for instance, okay, the option of receiver, not receiver, sorry, transducer as an option, then okay, of course, that would have been the one with the greatest. Had asked about as okay, the lowest. Well, okay, that's what we have on the left here is going to be as okay, the display will have the lowest what you want to call it, yes, okay, dynamic range. At least from it's okay from the components that we have on the list here. That's okay of our lowest, yes, okay, dynamic range that we know of is going to be yes, okay, our archive. Did you ladies get that? Did you girls get that?
Yeah.
Now the next question that they ask is okay, yes. Now why is it necessary for a receiver to perform compression of the electrical signal as it processes? Now the whole purpose of we can say is okay, decreasing
dynamic range is mainly as okay, just okay, make sure that okay as the upcoming component of the system doesn't get okay, we can say okay bombarded with too high of a grayscale or too high of a dynamic range. Okay, for it to okay to be able to handle. Okay, did that make sense? So that's why it's okay. It's mainly okay. It's processed. It is compressed. Or because it's okay. The dynamic range is decreased as okay as the signal travels from component to component to component to component to component. Mainly as okay to make the signal suitable for okay the upcoming component. Okay, suitable in what sense? Okay, what is it that will be able to? You can say handle. Okay. Did that make sense? $69. Sorry, $469. Now, a signal with 120 decibel dynamic range is compressed by 40 decibels. So you can mean it as okay that we had okay as the uncompressed signal had a dynamic range of 120 decibels. It is compressed. So you can mean it's okay compressed by, so that's going to be as okay. The degree of compression is going to be 40 decibels. And what they mean is okay, just ask okay then what is going to be as okay the dynamic range of the compressed signal. That's why we mean it's okay, just subtract these two and get a total of 80 decibels. Is that clear? Did you guys get that? Okay, whereas okay, if they have given us, let's say it's okay, this value here and this value here, and had asked that you calculate this, we will add these two. Clear? Or had they as okay, still giving us this value here and giving us this value here. We will still had okay, subtracted these two to get this. Did you girls get that? Okay, I guess that's what they just did in okay, that's the following question. Let's just see what it says. Because okay, a signal with a okay 120 decibel dynamic range was previously compressed by 40 decibels. Okay, so here is okay, we can say it's okay. The compressed signal, it is already compressed, but it has okay has a dynamic range of 160 or 120 decibels. Where we can say it's okay, the degree of compression was 40 decibels. Okay, so what is okay the original, or what is the dynamic range of the original uncompressed signal? Which is going to be as okay 120 plus 40, which becomes 160 decibels. Did you girls get that? Did you girls get that?
Yes.
Okay. Now, which display is limited to a single pair of brightness or display levels? Now, girls, please. A single pair. Where pair maybe there's going to be a collection of two. Right? Pair of shoes, pair of gloves, pair of socks. But here what they mean is just saying it's by a pair of brightness or display levels. Where as one of the pair would be black and the other side of the pair would be white. So that was what we called bistable. Did that make sense? At least for the options that we have here. Even if it just says yes, a bit or just bit also have been the correct answer. Did that make sense? Because it's no other one bit. Well, just give us two sheets. Which were black and white. And we only had black and white. Now recall being space table. Clear? So the actual phrase that makes it is bistable, the correct answer, and not the grayscale. Is because it says a display that is limited to a single pair. If you took that limited to a single pair out of the equation, yes, would have been a bright scale. Was a grayscale, sorry. Did that make sense? Did you ladies get that?
Yes.
Good. 472. Now, all of the following are consistent with an image containing black and white only, with no shades of gray, except from. So here we mean is just have to find out the ones which are not bistable. It can't be option A because option A means it says bistable. Option B, now where we know about something which is bistable, yes, it's going to have as a high contrast. Right? Okay. But due to yes, okay, this high contrast, we can mean yes, okay, just translate it into yes, okay, that's going to have okay as a low grayscale. And that means yes, okay, brings us to yes, okay, our last option, which says Y dynamic range, which means or mean great grayscale. Right? Which doesn't apply to this, okay, when we want areas, okay, to is okay, colors or okay within the image, which is black and white. Or this wide dynamic range, a great grayscale here could also have meant greater compression. Now question 473. Now which of the following term is not associated with a wide dynamic range? So what do we mean? Okay, what do we mean by okay as a wide dynamic range? We should already okay be able to say like that, or mainly mean okay as a great grayscale. Now great grayscale mainly will mean that okay yes that we will have a lesser contrast. Or we can say yes okay a greater contrast resolution. Okay. Now the first option that we have is okay yes low contrast. Okay, that fits here. Right, okay. The next is okay as many shades of gray. Okay, many shades of gray. We're going to get grayscale. Last is bistable. Now that doesn't make sense because bistable is mean it's okay going to be. Okay, forget about a wide range. Forget about a grayscale. Grayscale. Forget about is okay lowest contrast and best contrast resolution. Bistable is everything that's opposite to all of these. So that's okay, a low dynamic range, a low grayscale, or the lowest grayscale, greatest contrast, and we can say it's okay, poorest contrast resolution. Did you ladies get that? Yes, girls. You can pretty much okay, yes. Whatever that okay, yes, you mean yes, okay, just summarize this whole chapter down to something like this. Or this. And remember this. So the reason that is okay, I go on slowly. I can't go slower than this goes. Right, okay. It's mainly as okay, to me as okay, make sure that okay, yes. The dynamic range of information that you are given on a daily basis is not going to be more than you will be able to handle. Did that make sense? Otherwise, that's okay. I wanted to, that's okay. I could finish 3 chapters in a day. Then you say, okay, who is going to process that? That's going to be too much information for you girls to chew on, right? Okay. But if you girls say, okay, oh, they're still going too fast, no. When I started teaching physics, yes, okay. By now they had been done with the book. So we were just revising. But then comes, okay, the matter of, okay, as you were, what do you call it? Lesson plan. Okay. Was a different way of looking at the things that part of me. Now, girls, tomorrow and the day after tomorrow is okay. We will be doing a little, yes, okay, you can say it's okay, abstract chapter, which is chapter 17. Okay. And just so you guys know, yes, okay, that's going to be, yes, okay, the last chapter on your upcoming quiz, which I think is on this 18th. So the chapters for quiz 3 is 15, 16, and 17. Yeah.
So just for future references. So when we come back for vacation, you think we're gonna start on 18 or do you wanna start this week? Because next week is vacation, that's what I'm asking.
Yeah.
Okay.
So we'll be starting with chapter 18 then. Okay. What I would like to do on, okay, Friday is, yes, okay, show you girls some of the functions on the system. Okay. What we can mean is okay, mainly is okay, a lot of focus over receiver functions. And we didn't get the chance to do that, okay, this Friday because, well, okay, we had to go through a quiz again of, okay, some 96 or 98 questions. Right, okay. So, on Friday, yes, okay, when we come in for the quiz, yes, okay, just make sure that you have your, or Thursday, is it Thursday?
Friday.
Friday, okay, yeah. Okay, that sheet that I gave you, that practical sheet, have that with you, okay? If you want to, yes, okay, you can still bring in your book. But most likely, yes, okay, will yes, okay, show you some of the, it says, okay, functions on the system. Okay, functions that we have talked about so far. So yes, okay, for tomorrow's chapter, there's really not much that I can say that you can do to prepare for it because it's an isolated chapter. Yeah. If you go specific, yes, you definitely want to, yes, okay, just know, yes, okay, where is the relation between number of pulses and your temporal resolution? A number of pulses and what the hell do you call that? Exit resolution. Okay. You can just look at, okay, as your axis of the graph as well from chapter 1. Well, yes, okay, this is a little isolated chapter. You know, for the second part, yes, okay, you can start as okay, looking at okay, what does contrast mean? Now, I hope nobody should be in doubt now what the word contrast mean. Is there anybody who's still in doubt? Okay, girls, then I guess I see you ladies on okay, tomorrow. Same time, same place. Unless somebody has a question to ask. No? Okay, ladies, then have fun then.
Thank you.
You're welcome, dear.
Thank you.
You're welcome.